Okay. You came back. It's good. So I talked in the first section on this idea of the business of API, why we need them, and what power they can allow us for distribution. But how do we build them? How do we create the infrastructure needed to allow us to create platforms, to create products, and to create these channels? So that is this notion of microservice. Who has heard this word, microservice? Ah, very good. So you may know it by another name, SOA. Yes, so we have had this notion of architecting components for many, many, many years. Microservice is a sort of different way to explain or think about the same service orientation we've had for a long time. So I'm not going to go too deep into the details of this slide, but I want to sort of give you an idea. Companies like Amazon and Netflix and SoundCloud, there's a service called Guilt, and Etsy and several other ones, have been working on how to optimize service-oriented architecture over the last 5, 6, 7 years. In this optimization, this thinking about how to actually make it work, started to be published and talked about by some individuals. Martin Fowler of ThoughtWorks, Adrian Cocroft of Netflix, now with a venture company called Battery Ventures, and Sam Newman, who is also a ThoughtWorks consultant. So they started to find common patterns from these digital native companies. These digital native companies had a real focus on the cloud and on this fast-moving DevOps pattern. So it affected the way they decided to design the software itself, not just the way they tested and deployed it. So many people think really that it's very much still like SOA. It's just named different with some new tools. And I think that actually can be close. Amazon's head of technology, CTO, explained their way of doing business as SOA done right. Right? So in his mind, microservice is really the same thing. This is a kind of boring history slide we don't need to spend a lot of time on. We used to build these waterfall projects where we would decide everything first and then execute on that plan until it was done. This usually took 1 or 2 years. This was done at a time in the 90s and before when we would build the system and it would last for a decade. Many of the systems we use today, like banking systems, reservation systems, were built this way because they last a long time. The challenge is, as we moved through the last 15 years, through the rise of service orientation and the use of Agile as an implementation tool, the introduction of cloud and continuous delivery and continuous integration, and the decentralization and the DevOps era, software doesn't last 10 years. The solution lasts maybe a year. So taking a year to create something that lasts a year is a terrible idea. It's slow, expensive, and it never ends. IT becomes a constant expense that never gets recovered. So to attempt to solve these problems, Netflix and Amazon and others have taken to shortening this period of development. So we've moved from waterfall to this microservice idea. Now, lots of things actually come together to make this microservice idea work. because it's really just a theory until I can actually make it work. So over the last 8 to 10 years, we've seen continuous integration, continuous delivery become more and more powerful, more and more consistent. Cloud computing reducing the cost of a server and also reducing the time to get one. Netflix tells a great story. They changed all of their on-premise servers to cloud servers. It took several years. It used to take them 2 to 3 months to get a new server approved and into their on-premise rack. Many approvals. Then they moved to the cloud, where all they need to do is press a button to get a new server. When they first moved to the cloud, it still took 2 to 3 months to get a server. Why? Because they were still using the old process. So it isn't just that we have the technology, we have to change our process. So cloud computing means instant provisioning. At Amazon, they give every employee a credit card to start their own Amazon servers. And when you spend all your money, you have to ask for more. They don't say, they just say, here's $500. Start as many servers as you want. You don't have to have permission anymore. Web APIs, we've talked about the movement of DevOps, this idea of taking Agile and applying it to infrastructure for testing and release automation and constant delivery. More use of open source. PayPal has an open source inside their company. Every developer starts a new open source project with one button. And that open source project is available to all the other employees. So they share their code. Lots of JavaScript is becoming more popular in a lot of these digital native shops, more popular than Java or C#, or even some Erlang, there's some other languages. Use of GitHub as a social way to connect to developers. Many companies release parts of their software on public GitHub servers so that they actually attract new employees. Oh, I have used Netflix's tools. Then I'm already trained to be a Netflix employee. And the use of containers. Do we know this Docker? Has anyone begun using Docker, right? Docker makes EC2 look slow. Where Amazon to spin up a new server takes me 5 to 10 minutes. Docker takes me 30 seconds, making that even shorter. And this all results in new patterns that take advantage of all these things. When I can have constant integration in cloud computing connected through APIs with automated testing and release on open source, I can change the way I design my software. I don't have to design it the way I did 10 years ago. So Sam Newman writes a book called Building Microservice, very good book. I highly recommend it. It's a good sort of introduction to microservice. And he calls out several key points that make microservice valuable. I'm going to focus on one that he mentions, optimizing for replaceability. One of the patterns in many customers who use microservice that we've interviewed is they have this rule. If they have a component running and they decide they need a new feature, they don't change that component. They create a new one. And they get rid of the old one. They don't change software that's running. They replace it with new software. And this replaceability means I can keep my code very small and very simple, very easy to understand. Not complex if, or, else, then. Big code? No, small. Now, we also reviewed a gentleman by the name of Matt Miller, who's a venture capital investor in the US. Venture capitalists have a unique idea about this microservice. They think it adds a lot of efficiency and agility to the startup company. Rather than great big investments, lots of small investments. When you kind of combine these two things together with the features that Sam Newman talks about and the effects that venture capitalists talk about, it starts to look very similar to some of the things we talked about in APIs. Reducing cost, increasing revenue. Growth and adoption, cost reduction. So this microservice matches a great deal with APIs. The next section, I'm going to kind of talk about three basic ideas. The idea of how I decide the size of a module. This has actually been discussed for 40 years, 35 years. The idea of a domain, a problem domain. Whose problem am I solving? Remember the difference between your API, your private API, and the API for the partner, right? Whose problem am I solving? And then finally, something that we're seeing more of now than we saw in the past is thinking about the overall system, not just my software, but in my entire company. There are people in HR, there are people in finance, there are people in sales. They all have their own software. If I add new software into this, how do I affect them? I'm not just building one thing anymore. I'm actually affecting a big system. So microservices thinks about system. Okay, so Brian Arthur has this interesting idea. He says modules or components in software is really very similar to division of labor in manufacturing. So I have manufacturing line and I have everyone doing one thing, right? I place the engine, I use the steering wheel, so on and so forth. Modules in microservices each do one thing and one thing well. This is a quote from the people who designed Unix software. So if I do one thing and one thing well, it's rather simple. It's easy to tell if I'm doing my job correctly, right? If I'm actually placing the steering column in the place properly. And it's the same for software. If my job is to compute the sales tax and nothing else, it's easy to know whether or not my software is working properly. So modularity becomes incredibly important. It leads us to create parts that are smaller. So there are lots of sort of suggestions about how you can think about modularity. There's a thing called Heroku's 12-factor system. There's this idea of encapsulation spoken about by Martin Fowler. But the way to think about it from our standpoint, from organizing things, is we want to componentize our infrastructure so that we can make small changes. We can evolve the architecture. Evolving doesn't mean that things magically change. It means small changes over a long period of time. So if I can make a small change today and improve the quality tomorrow and tomorrow and tomorrow, eventually I have a very high quality product. But there's a problem with this idea. I can make the modules so small that it's just a pile of dust. There's no house here, this is just a big pile. So we have to think about where we make these divisions. And it turns out that's where this notion of problem domain becomes important. So 10 years ago, Eric Evans wrote a book called Domain-Driven Design. Very good book. It's a bit old now. 10 years is a long time on the internet. Many things have changed. But his basic notion is very good. Some developers refer to this as DDD, like domain-driven design. And what he's focusing on is knowing what your problem is, what you're solving. I'm trying to solve your problem, not mine. And in doing this, he mentions a lot about a phrase in English, bounded context. The boundary of the service or the problem you're solving. I'm solving the accounting problem or the shopping problem or the product pricing problem. You draw the boundary. And that boundary becomes your component. There's another version of this story that Microsoft came up with about 7, 8 years ago called CQRS, Command Query Responsibility Segregation. Sounds very fancy. It's really quite simple. The difference between read operations and write operations. Most of our computer systems, about 80% read, about 20% write. Separate those, both can go faster. Mostly Microsoft invents this because of SQL Server. How many people know what a dirty read is in SQL Server? Dirty write, yes, these problems we have, right? So they invent this notion of separating them to avoid this problem. There's one other thing that I really like, this story, Jobs to be Done, by a gentleman by the name of Clayton Christensen. There's a link in the slides, you can follow it later. He tells a story. I want to hang a picture on my wall, photo of my family, which means I need to put a hole in the wall where I can put the screw, right? So I have to go to the store to buy a drill. I don't really want a drill. I want a hole. The job to be done is the hole. If I could get the hole without the drill, I'd never buy the drill. Often we are in the business of creating drills, and we forget that people just want a hole. So focusing on the job to be done gives us some freedom to rethink. Much of Agile is about rethinking about the job to be done. Why do I have a meeting? I don't need a meeting. We rethink. Okay. So this idea of boundaries is important for microservice, but the thing about it is it's very, very artsy, not science. There's no way to simply decide. Even more frustrating is once you define the service boundary, it will change. We know this from all of us who design software. Our stakeholders explain to us exactly what software they need, and we go for many months and we build it and we deliver it, and they say, oh, well, the rules changed. We don't do that anymore. Right? So the boundaries change. So it's important to design with domains and boundaries in mind and create an infrastructure that lets me change that over time. That's why we have small units and continuous integration to allow us to make these changes. All right. Let's talk about this other idea, this idea of systems and how systems work. We're doing good. So this is a long sentence from John Gall in this book called Systemantics. I highly recommend this book. It's a very enjoyable book. And he says, a complex system that works has evolved from a simple system that works. A complex system designed from the beginning never works and will never be made to work. You have to start from simple. And many of us who built software sort of understand this, the way this works. The way you create something is to keep it simple. But that can be a real challenge because most of us create something that's simple and we keep adding more and more and more, and then it's no longer simple. It's now complicated. And someone says, oh, I want to change this one thing, but now it's very dangerous to change one thing because it all starts to break. Because we have this idea of tight dependencies. Each part depends on some other part, and if I change one, it all falls down. So there's a way to think about this. John Gall says we must respect the system. We must respect that we're actually just trying to make small changes. We don't actually control IT, we only influence it. Right? Those of us who've worked in this a long time know that we can design something, but when it comes to real life, it never looks the same. Always has compromise. We never quite finish all the parts. It gets tough. So there's this idea of the butterfly effect. Do we know this idea? That a butterfly flaps its wings in the Himalayas, and there is a tornado in the US. A small change ripples to create very big complexities later. So we have to be prepared for this idea. And then I mentioned this other one. We don't control the system. We can only watch and influence it. So what happens in microservices is we're creating lots of small parts that we must watch more carefully. The biggest challenge in the future of microservice is not building small software. It's actually keeping track of it. Dashboards, monitoring tools, these are the real challenges. If you want to be a hero today for microservice, build great monitoring tools. We need them today. If you can solve this problem, you will be rich. Because it's the new challenge, it's the new future. There's a great story from John Gall on systems. He says, if you are changing the system to improve it, and every time you change the system it gets worse, then maybe you are the one making it worse. Stop changing the system. Often it's hard for us to simply let it go and let the system sort of find its own way. This seems very much not like what our engineering mind wants us to do. We think we want to control everything. Do we know this word canonical data model? Who knows this canonical data model? No? The one data model for the entire company. Never exists. Never. We spend many meetings, many years designing this model. By the time we implement it, it's changed. We don't control the whole system, just different parts of it. Like traffic, car traffic, auto traffic. I don't control traffic, I'm just in it, right? We can change the way the traffic lights work, but we can't stop traffic. And that's a system. So, it's all about the system. It's all about how the system works. So, I mentioned Sam Newman earlier. Sam Newman has this great quote that basically says, microservices allow you to align the architecture with your team. Align the architecture with your team. This is actually referring to a thing called Conway's Law. Has anyone ever heard of Conway's Law before? Ah, very good, very good. Conway's Law is more than half a century old. And in recent years, it's become very popular. This is Mel Conway in 1967 when he writes Conway's Law. This is Mel last year. He looks very good, right? So Mel Conway still works today. We'll spend some more time talking about Mel Conway when we talk about culture. But he has this wonderful idea and this terrible sentence to explain it. It's terrible. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication. Communication dictates design. How we communicate is how we build. Many meetings, lots of arguments, lots of memos. That's what the software will look like. The larger the group of people who decide, the longer it takes, right? So I have a team of 5 people building software or a team of 100 people building software. Which one will build it faster? Always the team of 5 people. Always. This idea of how our teams affect the software is really important for microservice. In microservice, we affect the code by affecting the team. We'll talk some more about it in the next unit. That's what Conway's law is about. Communication dictates design. So, we really need a definition for microservice. It's hard to find people to agree on a definition. What we've put together is a definition to start, but I think it's too long. I think it has too many parts. An architecture style for building solutions that are network-based systems of services, modularized by domains, to improve all these things. Evolvability, deployability, composing, scaling, resilience, replace. That's a lot. But its influence, it's actually microservice really comes from the history of many people that have helped us build software over the last 30 or 40 years. Does anybody know who this person is? I don't think so. Has anyone heard of Roy Fielding? Yes, Roy Fielding is the man who invents REST in 2000. So Roy Fielding teaches us that you can have a style of software architecture, a style like Gothic style, or Romantic style, or Expressionism, or Pointillism. These are styles, right? You can have a style of architecture. And then Roy talks about how we want to build a solution to fit someone's needs. And John Gall tells us that it's all about systems. And Eric Evans tells us that domains and modules are important. Continuous delivery helps us create that evolvability of the system. And DevOps helps us deploy it on a regular basis. And we compose things by, just like we would on a manufacturing line because of Brian Arthur's comments. Amazon teaches us how to scale. Netflix teaches us how to build a system that runs even when there are errors. And we can replace small parts of it based on Sam Newman's ideas. These are the things that influence microservice thinking in just these last 2 years. It's been about 2.5 years since someone invented this word. And it's really a collection of all these things coming together. We find our customers who are working on this microservice idea are focusing on each one of these slightly differently. Some focus mostly on deployment. Some spend a lot of time on scalability or resilience. They're knobs that you turn. You don't have to do it all. You don't have to do it all at once, but you will encounter each of them as you're working. And what we find are large companies usually take a small group and start with this. They create a small team and they start experimenting on what's most important for them. One of the dangers of this microservice idea, for example, Netflix has released all of their software for you to use, their microservice platform. Well, the problem is Netflix optimizes for just one thing at all cost. For Netflix, being resilient to deliver that streaming movie is most important. They don't care about how costly it is. They don't care about how complex or composable it is or replaceable it is or any of those other things. So adopting just their software may be the exact wrong solution for you. You may need to focus mostly on deployability. Or you may need to focus mostly on how you can customize your solutions safely, right? Or all of these other possibilities. Or just focus on your domains or your customers' domains. So we're having a hard time distilling this into something simple, but we think these are the knobs, these are the features that we tune as we go forward with our customers. So far we're sticking with this long definition, but hopefully we'll get better as we go on. Okay, so there are some more references in the slides, don't worry about them now, about some of the material we're working on. And as I mentioned, we're releasing a book later this year, which will kind of distill a lot of this material, but hopefully this gives you some ideas, not just on the business value APIs, but the challenges for building them in this fast-paced environment. So that's all I have for right now. I take some more questions, and then we can take our 10-minute break if we like.